In this video, we're going to take a look at the exact trig values. So to begin with here, let's just start by recalling the trigonometric ratios. The way that we do this here is by using SOHCAHTOA. Let's just write down SOHCAHTOA. And we saw this in the previous video, so this shouldn't be anything new here. So we've got sine, cos or cosine, and then tan here or tangent. So let's say we've got sine theta here. And sine theta is equal to the opposite divided by the hypotenuse here. So it's O over H. It's opposite divided by the hypotenuse. That's our first trigonometric ratio there. We move on to cosine now, so cos theta here. And what we've got here is the adjacent divided by the hypotenuse. The adjacent divided by the hypotenuse. And then finally, for our final trigonometric ratio here for tan, we get tan theta. And this is equal to the opposite divided by the adjacent. It's the opposite divided by the adjacent here for tan theta. So that gives us our trigonometric ratios now. So what we're also going to give here is the exact trig values. So to begin with, what I'm going to do here is I'm going to give you the table. My advice here is to basically don't try and memorize this table. What I am going to show is how to actually derive these exact trig values, so you don't need to worry about memorizing the table. So to begin with, we've got our three trigonometric functions here. So we've got sine, we've got cosine or cos, and we've got tan. And the angles that we're looking at here are 0 degrees. We've got 0 degrees. We've got 30 degrees. We've got 45 degrees. 60 degrees. And then finally 90 degrees here. Okay. So what I'm going to do is I'm just going to split the trig functions up here. I'm doing this freehand. If you are going to do your own table, do use a ruler. Make yours look a little bit nicer than mine. We'll get something that looks like this here. Like so. And we just insert our columns here. We'll get something that looks like this. Okay. So let's start here by looking at 0 degrees. So sine of 0 degrees, that is equal to 0. That's going to be 0 there. Let me just split these off here at the top. So sine of 0 degrees is 0. Cosine then of 0 degrees would be 1. And tan of 0 degrees, that's also 0. Moving on to 30 degrees now. So what I've got here, for sine of 30 degrees, well, that's going to be 1 over 2, or a half. For cosine then of 30 degrees here, this is root 3 over 2. So root 3 over 2. And then for tan of 30 degrees here, that's equal to 1 over root 3. So 1 over the square root of 3. Moving on to 45 degrees now. Well, for sine of 45 degrees, that would give me 1 over root 2. Get 1 over root 2 there. For cosine of 45 degrees, that is also 1 over root 2. 1 over root 2. And then finally, tan of 45 degrees, that is equal to 1. We get 1 there. Moving on to 60 degrees now. Well, sine of 60 degrees is root 3 over 2. So root 3 over 2. For cosine of 60 degrees, that's 1 over 2, or a half. And then finally, tan of 60 degrees here, that is equal to root 3. And then finally, for 90 degrees here, well, we've got 1, we've got 0. And then for tan of 90 degrees here, we say this is undefined. So this is undefined. So that's our table there. Like I said, I don't want you to try and memorize these. It's not the easiest to memorize. So how do we actually derive these results here? Well, the way that we do this is by using two triangles. The first triangle here, let me just draw this. Obviously, we're using trigonometry here. These need to be right angle triangles. My first triangle here, we've got this right angle triangle. Obviously, my diagram isn't perfect here, but my base has a length of 1 unit. This slanted height here, so this would be the hypotenuse, this is equal to 2. And then this height here is root 3. But where does this triangle come from? Well, all I've done here is I took an equilateral triangle where my base is 2 units, and then my slanted heights here are going to be 2 units. Obviously, what I've done is I've split that up in the middle of them. So obviously, 2 divided by 2 means we have a base of 1 now. Then just using Pythagoras here, 2 squared minus 1 squared. We then take the square root of that, we get the square root of 3. Okay? I've used Pythagoras there. So this angle here would be 60 degrees. That's 60 degrees, meaning this angle here then must be 30 degrees. Okay? Obviously, the angles here must add to 180 degrees. And what we can do now is use the trig ratio. So using trig ratios, obviously I won't do all of them here, but I'll just pick a few out. We're using trig ratios. And what we can see, for example, is sine of 30 degrees. So sine of 30 degrees here. We're working with this angle now. So what that means is this base here, so opposite my angle, that would be the opposite. This would be my hypotenuse, and this would be the adjacent. So sine of 30 degrees, so that's the opposite over the hypotenuse. So my opposite here is 1. My hypotenuse here is 2, so we get 1 over 2, which is what we can see here. Sine of 30 degrees is a half. So what about, for example, tan of 30 degrees? Well, tan of 30 degrees here. Well, the tangent then is the opposite over the adjacent. So the opposite now is 1. My adjacent is this length here, which is root 3. We get 1 over the square root of 3 there. Okay? That's for when we're working with 30 degrees here. But because this triangle also has 60 degrees, then we can derive the angle measurements for 60 degrees here. So for example then, let's do it down here. Let's say we've got, say, sine of 60 degrees. Okay? So now we're working with this angle here. So what that means then is this length here, this root 3, would now be the opposite. It's opposite this angle that we're working with. This would still remain the hypotenuse here. It means this base now is the adjacent. So for sine here, that's the opposite over the hypotenuse. So my opposite here is root 3. My hypotenuse then is 2, so we get root 3 over 2 there. And you can see that that matches perfectly. So we then take a look at cosine of 60 degrees. Cosine of 60 degrees here. Well, cosine is the adjacent over the hypotenuse. So my adjacent here now is 1. My hypotenuse is 2. So for cosine of 60 degrees there, we get 1 over 2. So there you can see, using this triangle here, it's actually quite straightforward to derive the exact trig values. So what about now if we're working with 45 degrees here? So we do one more triangle then. Again, it's just going to be another right angle triangle, like so. Got my right angle here. So for this triangle here, our base is 1. This height here is 1. That means now using Pythagoras here, this must be the square root of 2. 1 squared plus 1 squared would give us 2. We take the square root here then to get this length. The square root of 2 there. So this angle here would be 45 degrees. And this angle here would also be 45 degrees. Okay. And from here now, we can obviously just derive the angle measurements then for 45 degrees. So for example, using this triangle here then, therefore say sine of 45 degrees here. Obviously it doesn't matter which of these two angles we choose here as our 45 degrees, they're both 45 degrees, so it really doesn't matter. But let's just say we pick this one here. So in this case then, my opposite here would be this 1, my adjacent will be 1, my hypotenuse here would be root 2. So for sine, that's the opposite divided by the hypotenuse. So the opposite is 1 divided by the hypotenuse here, which is root 2. we get 1 over root 2 there, and again, that matches what we've got here in the table. So let's say then we want tan of 45 degrees. So tan 45 degrees. So again, just using this triangle here and our trigonometric ratio. This is the opposite divided by the adjacent. My opposite here is 1. 1 for the opposite. My adjacent is also 1, so we get 1 over 1, giving us 1 there. Okay. And there we have it. So, like you can see, deriving the exact trig values isn't too tricky, as long as you're familiar with these two triangles here. Okay. But there we have it. So, that's everything that we need there for exact trig values. So, it brings us to the end of this video on exact trig values. In the next video, we're going to take a look at exam revision for trigonometry.